Dear student, I am Professor Shirbhate, Assistant Professor in Department of Physics, GS Gawande College, Umarkhed. Now in this video, we will discuss about the laser and its basic principle. Laser stand for light amplification by stimulated emission of radiation. Laser is a source of light which emit the light radiation which is very different than other traditional sources. That is highly coherent, highly directional, highly intense and highly monochromatic. Theory of laser. Now to discuss the basic theory of laser, we discuss about the interaction of light with the matter. We know that matter consists of number of atoms and they are distributed in a different energy level according to their own energy. And when the light which interact with the matter, we know that light consists of photon. When the photon having the energy h nu interact with the atoms of the material, then three basic quantum process will be takes place, such as absorption, spontaneous emission and stimulated emission. First one, absorption. Now consider the two energy level as shown in figure, that is energy level E1 and E2, and when the photon of energy h nu, that is equal to E2 minus E1 as shown in the figure, is incident on the material, that photon is absorbed by the atom, and when that atom absorbs that photon, then that atom goes to the excited state, that is energy level E2. Now during this process, the transaction of atom from energy level E1 to E2 takes place, and hence the transition of atom from the ground state E1 to the excited state E2 is called as absorption transition or induced absorption, and that process is represented by mathematically as shown is in the figure, that is A plus h nu equal to A star, where A represents the normal atom, h nu represents the energy of the photon, and A star represents the atom present in the excited state. Now second one is spontaneous emission. Now in first process, atom is excited to the excited state, and that excited state E2 is an unstable state. That's why that atom does not wait in that state for a longer time, and hence the process will be occur. Now in that process, without taking any time, that atom take a downward transition. Okay, and hence we can see that the spontaneous emission is the process in which emission of photons takes place by an excited atom by its own without any influence of the external agency or agent is called as a spontaneous emission. Okay, and that process is mathematically represented by A star equal to A plus h nu, where A represent the atom present in the excited state, A represent the atom in a ground state, and h nu represent the energy of the emitted photon, that is a spontaneously emitted photon, and all the process will be explained in the given diagram. The third is a stimulated emission. Now as in a second process, that is a spontaneous emission, atom is already present in the excited state, and excited state is an unstable state, and hence that unstable state have some particular lifetime. Okay, now without waiting for that lifetime, if we apply some force on the atom present in the excited state, then stimulated emission will be occur. Now in this process, when the photon excite or incident on the excited atom, then that photon trigger the excited atom and transaction will be takes place. That transaction is called as the stimulated emission. Now the process in which emission of photon takes place by an excited atom under the influence of the external agency, that process is called as a stimulated emission, and that process is mathematically represented as A star plus h nu equal to A plus twice h nu. Here again A star represents the atom present in the excited state, h nu represents the energy of the photon which is used to trigger the atom present in the excited state, A represents the atom present in the ground state, and twice h nu represents the energy of the photon emitted by the excited atom and the energy of the initial photon, that is we represent it as a twice h nu. Now in these three processes, we follow that these are the basic process by which we obtain the light radiation, and for the most amplification of the light we require the third one, that is a stimulated emission, where the atom is already present in the excited state. Now if we require atom must be present in the excited state, we require the population inversion. Now generally in a thermal equilibrium state, the number of atoms present in the ground state is always less than the atoms present in the excited state, that is N1 is always greater than N2. But to achieve the population inversion, we require more number of atoms will be present in the excited state, that is N2 should be greater than the N1. That's why we require one condition, that is where the atoms will be present in the excited state as compared to ground state. That type of situation is called as a population inversion. Population inversion is a condition in which population of the upper energy level is always greater or far exceed than the population of the lower energy level, that is N2 is always greater than N1. That's why that state is called as population inversion. The inversion word is that because the population of the population inversion state is completely inward than the normal state, and both the exam or both the diagram will be displayed here for the normal state and the population inversion. Now to achieve the population inversion, we require more number of atoms will be present in the excited state. Okay, and we know that excited state is an unstable state having a particular lifetime. Means that to achieve the population inversion, we require one state where atoms will be present for a longer time. That's why we need a metastable state. Now metastable state can be defined as a state where the excited atom can remain for a longer time than the normal state or normal excited state. Metastable state, in the metastable state, atoms stay for a longer time, maybe from 10 to the power -6 to 10 to the power -3 times. This is 10 to the power +3 to 10 to the power +6 times longer than the time of the stay of the atom in the excited state. If the metastable state does not exist, then there could be no population inversion, no stimulated emission, and hence there is no operation. Okay, now in the case of laser is nothing but one device, and the device consists of some few parts, or we can say that the component of the essential which is required for the laser device is active medium, pumping agent, and optical resonator. The active medium, a medium in which light get amplified, is called as active medium. Now in the case of laser, there are three parts. One is active medium, then pumping, and the optical resonator. At the middle stage there is active medium. Active medium, what is active medium? Active medium is a medium in which amplification of light takes place. That medium is called as an active medium. That medium may be solid, may be liquid, or may be gaseous, and in that active medium few atoms play a role to take part in the stimulated emission. That atoms is called as the active centers. Therefore active centers are those atoms which are responsible for the stimulated emission. Pumping. Now to achieve the population inversion, we need to supply some energy to move the atom from ground state to the excited state. That process is called as the pumping. That's why the pumping is the process of supplying the energy to the medium with the view of to transfer it into the state of population inversion. That process is called as the pumping. There are several techniques to achieve the state of population inversion, such as optical pumping, electrical pumping, and direct conversion. Dear student, in this video we discuss about the basic principle required for the laser operation, such as the principal operator, which include the three processes, then population inversion, metastable state, and the process of pumping. Thank you for watching this video.